Hi everyone, and thank you very much for watching this video. My name is Julia, and what I'm going to show you today is how to isolate exosomes by using the exosome isolation kit from CellGS system, which is Exosome. So basically, this kit combines two really powerful methods, which is precipitation and then size exclusion chromatography. And we will ship all that you need in this kind of boxes. Well, you will find our exospin buffer, which is needed for the precipitation step, as well as our size exclusion chromatography columns, waste tubes that you will need during the size exclusion step, and we also provide PBS. So we provide PBS minus to be sure that the PBS that you will use will not interfere with any of your downstream application. Something else really important is the user guide that you will find when we will ship the Exospin kits. So it's a really valuable document with a lot of information about exosome isolation in general, and more importantly about our kits. So please read it really carefully before using our columns. So today what I'm going to show you is the steps on page 6. So if you have the user guide in front of you, you can follow with me, and if not, you can also download it on our website. So I'm just going to show you the purification of exosome steps, so not the precipitation, because it's a bit longer. So basically the precipitation step, you just add your buffer with your sample together, you mix it, and then you put it in the fridge at 4 degrees from 1 hour to 12 hours. Then you put it out and you will see that you have a pellet, and this will be your exosomes. And then you put out the supernatant, you resuspend your pellet in 100 microliter of PBS, and then this sample, so it contains exosome but as well as protein, etc. So this is why we have the size exclusion chromatography step that will allow to purify your sample of all other components that are not exosomes, basically. So as I said, I'm going to show you today how to use our columns. So this is how they look like. The first step in the protocol is to calibrate the column. So to do so, you first have to put out the plug and then to open the screw cap. Because there is a preservative buffer inside of the column, it will start to elute directly when you're going to pull out the plug. So this is why we provide waste tube. So when I'm going to open the plug, open the cap, and then I will put my column inside of it. So now I'm going to start by putting out the plug, then opening the cap and putting it straight away into the waste tube. So you will see that on the top of the column there is the buffer remaining. So the first step is to pipette it out. So when you do it, do not hesitate to touch the top of the column. It's not going to damage the column at all, and it's better to put all the buffer out than be afraid of touching it and then having contamination with your sample. And now, so the column should not dry. So to do so, you have to go straight away to the next step, which is to add 250 microliter of PBS, which is here. So this is the PBS that it's given as well in the kit. So you put it on the top of the column, and you centrifuge for 10 seconds. So it's a really low speed, it's 50 G. So you don't have to put the cap on the column. You can just centrifuge it like that, and it's 10 second centrifugation. So you will see in the user guide that we mentioned that you can centrifuge 5 more seconds if there is PBS remaining on the top of the column. So you will see, you just need to have a look and you see if there is PBS. So for me, everything is clean, so I don't need to centrifuge for 5 more seconds. And then just in order to be sure that all the column is clean of any ethanol, we ask you and we recommend to repeat this step. So you do the same step again, and then you centrifuge for 10 seconds. And so at the end of the second centrifugation, you will see that your waste tube is full of PBS and of buffer. So the first thing to do is to discard the flow through and then put back your column in. Now your column is completely calibrated and is ready to receive your sample, which is the 100 microliter of the precipitation from the other step. So me today, I'm not going to use sample because I didn't do the precipitation step before, but I'm using trypan, which is a blue dye. It's a really good method to show you the size exclusion chromatography method, basically. So I'm going to use it as it is a sample. So I'm adding 100 microliter of this blue dye on the top of the column. As if it was my sample. And then this time you centrifuge for 1 minute. So now it's been 1 minute, and what you see at the end of this first centrifugation, when you look at the column, is that the dye went inside of the column. However, it still stay at the top. So our pore resin size is 30 nanometers, so everything that is smaller or equal to this side will have to go through all these pores, and so it will be much longer for them, for the protein and for the small molecules, to go through the whole column to actually elute. However, the exosome, because they are a bit larger than 30 nanometer, they will go through the column much faster than all the protein, etc. So this is all your protein that gets stuck. This is the remaining of PBS that was in your column, and then we just have the last centrifugation. So it's 1 minute again, and at the end of the last centrifugation, you will have your purified exosomes. So at this stage, what I do is that I bin the waste tube, and then I put my column in a 1.5 milliliter of microcentrifuge tube in order to receive my purified exosomes. And before putting the column again, I just add 200 microliter of PBS on the top of the column one last time. And I centrifuge again for 1 minute. Okay, so now it's been 1 minute, and what you see at the end of your final centrifugation is that here there are your 200 microliter of purified exosomes, which are ready for any downstream application, as well as to freeze if you don't have time to do it straight away. And regarding the column, so what you see is that the dye continue to elute through the column. However, it still gets stuck quite a lot on the top still. And this is what allows you to have a really pure sample at the end of this step. So the column will be stuck with all protein, all small molecules, and here you will have highly pure exosomes. So I think it's the end of this video. Thank you very much for watching. I hope it was informative and that you will be happy to try. So as I was saying, it's a really easy protocol, and I'm also always happy to support you if you have any questions before or after trying our columns. So thank you again, and do not hesitate to put a comment and tell us your feedback and what you think.